Right, we've got 2 points, which is the diameter of a circle, and we've got to show that the centre of the circle has those coordinates. Well, what it's really asking is what the midpoint of the line AB is, because the midpoint of AB will be the centre of the circle, right? Is centre of circle, because AB is a diameter. So in other words, we've got AB, I think, goes something like that. Okay, point A here is minus 211, point B here is 8,1. Because AB is the diameter, that means that the centre of the circle is obviously the midpoint there. Okay, now how do we find the midpoint of a line where we've got the coordinates of the ends of the line? We just add together the x coordinates and divide by 2 and do the same for the y coordinates. So minus 2 plus 8 over 2 and 11 plus 1 over 2. So in other words, M, the midpoint, is minus 2 plus 8 over 2 and 11 plus 1 over 2, which is minus 2 plus 8 is 6, 6 over 2 is 3, 11 plus 1 is 12, 12 over 2 is 6. Only one mark, and we've done it. You do need to know the formula for how to work out the midpoint of a line. Right, next part. Oh, it's not, it's part 1, isn't it? So part 1, find an equation for C. Well, in general, the equation of a circle will just be x minus a squared plus y minus b squared equals r squared, where the centre of the circle is given by AB, and r, of course, is the radius. Right, so we've kind of got the left hand side because we know the centre's 3, 6, so we can say x minus 3 squared plus y minus 6 squared equals r squared. So what we're really going to have to do is to find the radius of the circle. Now, however, we've got the 2 endpoints of the diameter. So what we can do is we can say, right, if we can find the distance from A to B, that will give us the diameter of the circle, and if we divide it by 2, that will give us the radius. So how can we find the length from A to B? Well, it's Pythagoras, so AB squared is going to be the difference in the y coordinates, all squared, which is 11 minus 1 all squared, plus the difference in the x coordinates, which is minus 2 minus 8. Minus 2 minus 2 minus 8 all squared. And that, of course, is 10 squared plus 10 squared, which is 200. Okay. So the diameter AB is equal to the square root of 200. So whoops. Right, so A, let me change the colour, do it back in blue. Right, so AB squared we know is 200 using Pythagoras, and that's the change in the y coordinates all squared plus the change in the x coordinates all squared. That means that diameter AB equals square root of 200, and that means the radius is going to be the square root of 200 over 2. Right, which means that the radius squared, which is what we want here in our equation, is going to be square root of 200 squared, which is just 200, divided by 2 squared, which is 4, which gives us 50. and then we've done it then. So we get, you can see it's written here, I've done it before. So we've got x minus 3 squared plus y minus 6 squared equals 50. And that's the equation of our circle. What we have to do now, I think, is verify that the point 10, 7 lies on the circle, and then we've got to find the equation for the tangent at that point. So, part C, verify the point 10, 7 lies on C. Well, C, the point 10, 7. All we're going to have to do is substitute x is 10 into the equation and substitute y equals 7 into the equation, and hopefully then the left hand side there should equal 50. So we've got 10 minus 3 squared plus 7 minus 6 squared is the left hand side, and that's going to be 7 squared plus 1 squared, which is 49 plus 1, which equals 50, which is the right hand side. So we've done it. We've verified that our x and y, where x is 10 and y is 7, fit the equation. So therefore 10, 7 verified as on circle. Now we have to find the tangent now at the point 10, 7. Right, now you work out the tangent, the equation of a tangent, by realizing that the gradient of the radius times the gradient of the tangent has got to come to minus 1 at the point where the tangent meets the radius. So if I've got a circle, here's a circle, and I've got the centre there, and the centre's the point 3, 6, and we're looking at the point 10, 7, which is, I don't know, about there. That's the point 10, 7, and we're looking at the radius, which I'll try and draw, not very successfully. Try that again. So right, try and draw another line. Again, not great, but it's going to look something like that. What you need to realise is that the tangent from the centre to the point, that has got to be at right angles to the tangent. Okay, so the gradient of the radius is going to be change in y, 7 minus 6, divided by the change in x, which is 10 minus 3, which is 1 over 7. Therefore, that tells us that the gradient of the tangent is going to be minus 1 divided by that, or in other words, minus 7. But we know it goes through the point 10, 7. So we have y minus 7 equals minus 7 lots of x minus 10. So if I get it in the form y equals mx plus c, we have y equals minus 7x plus 70 plus 7. In other words, minus 7x plus 77. And that's the equation of the tangent at that point 10, 7.